In this lecture, we're going to take a closer look at a graphical representation of the standard deviation, as well as two other measures of data variability. And so the standard deviation is based upon the normal distribution. And by definition, the standard deviation accounts for approximately 68% of all the scores within a sample or a population that can be fit to this normal distribution. And so 68% or approximately 68% of those scores are described as residing within plus or minus one standard deviation above and below the average. And in this example, if we have a population or a very large sample of individuals that have an average age of 80 years, we might find that the standard deviation of this sample or population is plus minus 5 years. And so we go to our graph here along the x-axis is outlining the distribution of the outcome variable, which is age. And here we see that line of symmetry for the normal distribution with an X bar. The bar is slightly shifted to the right, but it should be over the X. And that indicates the average age of the individuals within this entire sample. And with this calculated standard deviation of plus minus 5 years, we see that the distribution of the individuals, or 68% of the entire sample, resides within this within the standard deviation limits of between 75 and 85 years old. Now that leaves the remaining 32% of the entire sample, or 32% of the scores, outside of plus and minus one standard deviation. So the 32 is split between the upper tail, so those individuals that are older than 85, and the lower tail, those individuals that are younger than 75 years old. Now, the standard deviation is established based upon the approximately 68% of all the scores within a sample or a distribution. However, different shaped distributions can also be described by the standard deviation. So whether the distribution fits the standard normal distribution, or if the distribution is more leptokurtic or platykurtic, and we'll take a look at these here shortly, the same rules apply. So 68%, or approximately 68% of all the scores, will still reside plus or minus one standard deviation. They just happen to either be closer to the mean or farther away from the mean. And so what we see here on the left-hand side is a leptokurtic distribution, where the scores in the distribution reside closer to that line of symmetry, which is the average of 80 years old. However, what we see here, because this distribution is tighter with respect to the location of the scores near the average, we have a smaller or a lower value for the standard deviation, which is plus minus 3 years. And so even though we have a tighter distribution, this is still capturing the 77 to 83 years, is still capturing approximately 68% of all the scores. The platykurtic distribution just indicates that the scores, the majority, that all these scores relatively are located further away from the average. However, the symmetrical shape indicates that still 68% of all the scores are located plus or minus one standard deviation. In this case, the plus minus one standard deviation is plus minus 8 years. So we see 88, and on the lower end, 72 years old, will capture 68% of the individuals of the total scores within that sample. Another way to quantify the variability within a sample is through what's called the coefficient of variation. And the coefficient of variation is used for interval or ratio data, and these are data that are sampled along a continuum rather than individual categories. And what we see here is that the coefficient of variation is equal to the standard deviation of that sample divided by the average score of that sample. And recall that the standard deviation has the exact same units as the average score. So on our previous example of the average age of 80 years, the standard deviation was plus minus 5 years. But since we're going to divide 5 by 80 years, the years cancel as units. This produces a ratio of the standard deviation to the average, and we multiply that by 100%. And the coefficient of variation is a very useful measure of variation because the calculation eliminates the units. And so we end up with a unitless measure of variability that's independent of those units. And as such, we are now able to compare measures with different units where we could not do that when we have different variables that are quantified by different units. The variation is expressed as a proportion of the average, and this is a measure of relative variation and can be helpful when attempting to explain how variable scores are within a population relative to that average. The other manner in which the variability can be quantified is through what's called a z-score. And a z-score is calculated for any known individual score. And this is a relative value in the sense that the units are eliminated, and this will identify the location of one score within the entire distribution. And so in this equation, we see that X refers to a single raw score that's obtained from one unit or one case or one person in the sample. X bar is the sample average or the mean, and S is the sample standard deviation. Recall that the standard deviation retains or possesses the same units as the average, and since we're dividing the difference between a single score and the average by the standard deviation, the units eliminate. So here we see with a z-score, we have a recalculation of a single score within a sample to a unitless value. And so this does pose some advantages. The first advantage is that it assesses the relative position of each unit in the sample. And because it's calculated relative to the average, it will allow the identification of where each score resides with respect to the average, whether it's below average, whether it's above average, as well as how close or far away it is from the average. The other advantage is that the units of measurement is eliminated or are eliminated. And this allows a comparison, once again, between different dependent variables that exist on different measurement scales and different units. So this completes this brief lecture, this portion of our Unit 6 lecture on the standard deviation.